now let's look into the first tool of measures of shape, that is skewness. What is skewness? Skewness is a measure of the asymmetry or skewness of the distribution of the data. So before we see the definition of the skewness, so what I'm gonna do is I'm use meaning of, let me type skewness. Skew set placed or running obliquely, slanting. You see that slanting? This, keep this in your mind. More developed on one side or in one direction than another. It's not symmetric. It's not symmetrical. It's not symmetrical. Okay, that's the definition. What's the meaning of askew? Is slanting or developed on one side or in one direction than another. It's not symmetrical. That's what the definition. Now let's get back to the our definition. Okay, now, so skewness is a measure of the asymmetry of the data distribution. It tells us whether the data is skewed to the left or to the right with respect to the mean. So let's look into the following diagram. So in simpler term, we'll be looking into the uh, skewness, left skewness, and then right skewness, and symmetrical. So if the skewness is close to the zero, so after measuring the skewness, if the skewness is equals to zero, then the distribution is approximately symmetric, like this. And if the skewness is less than zero, if the symmetric if the skewness is less than zero, the distribution is negatively skewed. Okay, a negative side got skewed. Okay, on this side, positive side, you have huge amount of data, whereas in negative side you have very less amount of data. That's why it got distorted. The bell curve has got distorted on negative side. That's why we call it as a negative skewness. Similarly, if the skewness is greater than 0, if the skewness is greater than 0, the distribution is positively skewed. So here, so the positive side of the mean, this is the mean at the center. The positive side of the mean got skewed, got distorted. You see that? The tail is on positive side. So that's called positive skewness. In positive skewness, as the definition says, skewness is greater than 0. If it is greater than 0, positive skewness. If it is less than 0, it's a negative skewness. So now let's understand the same with an illustration. We'll use an illustration. First, let's see the zero skew. Zero skew or symmetrical skew. The distribution is very much balanced. The distribution is balanced and evenly spread around the mean. Let me do one more time. See, this is our symmetric curve with a skewness of 0. The data is evenly distributed around the mean. You see that if I draw a mean here, on left side, negative side, you have the same amount as the positive side. Okay, that's what is our 0 skew or symmetrical. Then we have a skew positive skew. We call it as a right skewed also, because here the right, here, see that the right portion has skewed, or the positive side of the plot has been skewed. So that's why it's called either right skewed or positive skewness, because the positive portion is skewed or right portion is skewed. And then the most importantly, if the skewness value is greater than 0, it's called a positive skewness. Let me do that. You see that? You see the shape? You have the more amount of data on negative side, whereas the very less amount is on right side, positive side. The tail of the distribution is stretched towards the left, and the majority of data, sorry, the tail of the distribution is stretched towards the right. You see that the tail of the distribution is stretched towards the right, and the majority of the data is concentrated towards the left of the distribution. So that's why we call this as right skew, right skewed, because the right portion has been skewed, right skewed, or the positive skewness, because the positive side of your plot has been skewed, whereas the negative side, the whole data has been concentrated towards the left of the distribution. Then the last one, that's a negative skewness. The negative skewness here, the tail of the distribution is stretched towards the left, and the majority of the data is concentrated towards the right of the distribution. And here you can clearly see that the negative values has been skewed, the negative side of the plot has been skewed, whereas the majority of data has been concentrated on the positive side of the data. As the left side has been skewed, we can call it as a left skewed, and the negative side of the plot has been skewed, that's why we call it as a negative skewness. Whichever side is distorted, that's what we call it as the we call that skewness with respect to the side which is skewed. If it is negative skewness, the negative side got distorted. If it is positive skewness, the positive side got distorted. Okay, let's take one example. uh, then we will understand the skewness with that example. Okay, so measures of shape skewness. So import pandas as PD. Then let's create a data frame as quick as possible. df is equal to pd dot data frame scores, and list of values, that's 66, 72, 84, 75, 90, 85, 77, 78, 89. By looking at, we can make it out which side it is leaning in. That's okay. Let's calculate the skewness now. Calculate the skewness. Skewness is equal to df scores df scores and then skew. So let me print the skewness now. Skewness is skewness. It's minus 0.3009. So what would it be if the skewness is lesser than 0? If the skewness is lesser than 0, what would it be? If the skewness is 0, what it is, and if skewness is greater than 0, what it is? I am asking you, just answer me the question. Okay, so if the skewness is greater than 0, it's obviously called as the positively skewed. But here in our case, the skewness is less than the 0. That means the distribution is negatively skewed. When I say negatively skewed, the negative side of the data has been skewed. So maybe probably that is gonna take this kind of shape. Let me take, okay, df dot, okay, scores. Yes, it has taken the negatively skewed. You see the shape? See the shape here? It's a negatively skewed. And let's explore more. Let me call the players data. Soccer players. Yes, as usual, I'll go with the height and centimeter. So players, height in centimeter. Let me measure the skewness first. Let me measure the skewness. So it's 0.18. It's closer to the 0. So as per us, if it is closer to 0, that is symmetric. Let's see the shape of it. How does it look? Players and height in centimeter. And let me draw the histogram. And fantastic. As it is symmetric. It's closer to the symmetric. That's how your skewness will convey the lot of information about your shape of the distribution. Shape of the distribution. Let me take one more example. So players, and this time I'm gonna take weight. So skewness, sorry, yep, it's 1.38. It's positive value. It's greater value. It's not less than 0. It's a positively skewed. When I say positively skewed, the values which are on positive side will be skewed. So that means the most of the data is on left side. Let's see. So with this, we can understand that so many players having the weight which is in between maybe 30 to 80, 90 kg. Let's see. Yes, absolutely correct. See that? See that? It's a positively skewed. The positives, the tail is on positive side. The data which is on positive side, the shape of the distribution on positive side has been distorted. The positive distortion is positively skewed. The value would be positive. And you see the most of the soccer players has a weight in between 50 to 100. So that is the reason. So most of the players are concentrated on negative side. You can say negative because here the mean is somewhere here. So negative side of the mean. Negative side of the mean. That's what it says. And let's take more data. Let's take customer buying patterns. So this is our customer pattern. Now let's go for the family size. First we will explore the family size, then we'll go for the annual income, because these are all real data. Let's see how they behave, because these are all natural data. So I just want to see their behavior. So customers, I'll go with the family size, and skew, it's 0.19. This is also closer, to the 0. Let's see the shape. Let me check the shape of it. Yep, this is not okay, this is 0.19, it's not 0. Okay, this is not 0.019, it's 0.19. So it's a positive value, so obviously it will have a positively skewed. Okay. Positively skewed. So the mean is somewhere here. And next, let's look into the one more. That's work experience. Let's see work experience. Okay, see, this is 0.68, 0.68, which is greater than 0, and which is much greater than the previous one. So this is also positively skewed. And let's see the shape. I think more data would be concentrated on a negative side of the mean. That's what I'm expecting. Let's see. Yes, absolutely correct. Absolutely. You see that? You see that? Everything has gone into the left portion. Everything has gone into the negative side of the mean. If you take this as a mean, exactly on the right side, you can tell them as a positive side, and left side of them you can call them as a negative side. This is how you refer them in normal curve, saying one, this is mean, and 1 plus sigma, 1 plus mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation on right side, whereas on left side, mean minus 1 standard deviation, mean minus 2 standard deviation, and mean minus 3 standard deviation. So that's the reason I'm calling this as a negative side. So if the positive side has been distorted, it's called positively skewed. Okay, now let me look into the annual income. Okay, see, let's see the age of the population, how they are distributed. Age of the population, let's have some fun. Let's check how our customers how our customers are distributed. So age. Okay, it's pretty closer, 0.049. It's pretty closer to 0. Let's check the shape. Let's check the shape. Yep, that's okay. It's neither positively skewed nor negatively skewed. That's what it's, some kind of neither uniform uh nor symmetric. Okay, some sort of shape. Next, annual income. Let's see the annual income. Annual income would be positively skewed. That's the natural phenomena. That's called Pareto analysis. But let's see how it goes here. Customers and annual income skew. Oh, it's gone negative. Oh, it's opposite way. So customers negative. So the value is lesser than 0. This is negatively skewed. Let me put it into the list. Yep, obviously negatively skewed. The negative portion has been skewed. So most of our customers are rich. Rich customers. Rich customers. That's okay. This is how the measures of shape helps us to understand more insights from our data.